Hi, and welcome to what I believe might be the first part of a series of videos that I'm going to call GH Sharp or Grasshopper Sharp. Because basically what I'm going to do in these videos is that I'm going to take regular vanilla Grasshopper components, the ones that come out of the box when you download it and install it, and the ones that you're probably used to working with. And I'm going to mimic and replicate their functionality with C# scripting components. I think this is a wonderful exercise to do because it is a good introductory lesson to learning how to do computational design, but instead of using visual programming languages, starting to find and write the same logic with actual code. I think it's also a really nice exercise to get to know better how Grasshopper works internally, and especially to get familiar with Rhino Common, which is the library, the geometry library that runs behind the scenes and that gives us all the power to work with points, vectors, lines, NURBS geometry, and all the real goodness. It's also a very powerful technique because if you have very complex Grasshopper definitions, writing them, condensing them inside C# components gives you a lot of performance, much better than just writing it with regular Grasshopper components. Okay, so this is going to be part one of a series where I'm going to break down, for example, the addition component, the numerical series. I'm going to do some basic geometry, so I'm going to create points, I'm going to operate with vectors, and I'm going to create lines. And you can see that each component has its mirror in C#, okay? And I'm going to explain from the very basics of how to do this. I want this first part to be a very introductory, beginner level video where I will take some time to explain what a C# component is, how to work with the inputs and the outputs, even though I will not cover too much in detail the actual C# programming language. I will hopefully have a series of videos at some point that you can reference to. Okay? So come on in and join me in creating or mimicking some standard Grasshopper components with C#. Let's get done. A good way to start this video is probably going to be with the simplest component that I can think of, which is the addition component. The addition component just takes in two values and then returns the simple sum of those two values. Okay, I would like to start with this one because I would like to go over the basics of how to deploy a C# script component, how to change the inputs, and how to make them work towards what you want. Okay, we're going to go to the basic script, C# script component. Oh, and I forgot, I'm going to drop a bifocals component here just for the sake of having much more feedback. And then you saw that I just dropped a C# component. The C# component, like any other component, has the inputs on the left and the outputs on the right. What's important when you start a C# script component is that you need to be very specific about which inputs this component is going to take. So two things that you would like to do is first you're going to want to rename them. So you can right click on the parameter input and then rename it to a particular name. So for example, I'm going to do A because I want to really mimic this component. And here I'm going to right click and I'm going to type B. Okay. I can also do the same for the output. I can right click it and rename it to R as in result. And then and then the second thing, and this is super important, is that we need to figure out what kind of accessibility input these parameters are going to have and what kind of types they're going to accept. When I mean accessibility input, what I mean is whether if these components are going to work with each one of the elements that are passed individually, are going to work with them as a full list, or are going to work with them as a full data tree. What that means basically is that it doesn't mean that, for example, if I choose item, it doesn't mean that it will only be able to take one single element. What it means is that it will perform the operation that it will perform with each one of the items on the list. Okay, and this perhaps will be a bit more relevant as soon as I show the next component, which will take a list of data as an input. Okay, so for the time being, we're going to leave A and B both at the item access level so that they perform individual operations with each one of the elements that are passed to this component. Okay, so if I give them a list of 10 elements, it will add each one of them at a time. The other thing that I would like to do for each one of the inputs is to work, I will need to define what kind of type this input is going to take. And this is important because C# is a strongly typed language, which means that whenever you declare variables, which is what these inputs will become when in the functions that are inside of the component, whenever we declare variables, we need to tell C# what type of variables those are. Are those numbers? Are those text? Are those strings? Are those vectors? Are those circles? We need to specify it because C# needs to do some operations, like it needs to figure out exactly how much memory it needs to find, how much memory it needs to allocate. So it needs to do operations that rely on knowing what type of data it is. This might be a little painful, but it also has a lot of advantages in terms of, for example, performance and compilation error checks and all those kind of things. So because we are going to be adding two numbers, I'm going to go to type hint, and I'm going to go to the top half, which is more or less the primitive values, and I can see that I'm going to click on double, which is the C# way of saying that this is a number that has double precision floating value. That is not correct. I think it's a double precision value, which means it's a number that has decimal part, but it also has a lot of precision, as opposed to, for example, floats, which are also have a decimal part, but they have a little less, they have half the precision basically. So I'm going to click on double here. I'm going to click on double for the other input B, and I'm not going to need to do item list or data tree access for the output, or I also don't need to specify the type of output, because that will be automatically defined inside of the component, and it will be, and Grasshopper will take care of that. So I'm going to plug in these two things here, these two inputs. I'm going to copy paste this panel here, and I'm going to now go in and start writing my code in the component. In order to modify the component and to start writing code, we're going to double click inside of the component here. And then what I'm going to see is this screen that has a lot of stuff, and I can actually expand and contract these like initial sections. We're not going to get into what any of this means today, but I just want to let you know that the important stuff is this function here. This is a C# function, which is the function that is executed every time this component needs to yield a solution from the inputs. And interestingly, you can see that the function is called runScript, which we don't really care about, but what we care about is that the inputs, so A as a double value, B as a double value, and R as an object that we output, those have been already set automatically by Grasshopper given the inputs and the things that we have set here from the interface. So if I were to change, for example, B to a list access of integers, right, we could see that B is not a double anymore, but it's a list of integers. So this we cannot change manually, we change it through the interface. Okay, I'm going to revert that. I'm going to go back to item, and I'm going to go back to double. Okay, and so it is here. Here we write our awesome code. It is inside of here that we can write the code that is going to be running inside of this component. So what is it that we want to do? It's going to be super simple. We just want to take the two input values, A and B, and add them together. So a way that we can do that is, for example, I can declare, if we're going to add two numbers, the result is going to be also a number. And if the two numbers have decimal precision, the result is also going to have decimal precision. So I can declare a variable of the type double to contain the addition of these two values. So I can say, for example, double sum is going to be equal to the addition of A and B. So A plus B. Okay? And once we have that, I can run this code, And you guys can see that it runs, there's no errors, etc. But I don't get any output here. This is important because we have made the calculation inside of the component, but we haven't really specified anywhere that that result should go out through the R component, okay? So through the R output. So that's why the last thing that we should do is here on the outputs, we should say the value of R is going to be equal to that number that I just calculated before. So sum. And as I do that, I now hit execute, and you can see that this value is being output by the component. I can change these two inputs, and you can see that it works exactly the same. So it looks like we're good to go. You may ask, oh, but isn't this a little redundant? So are you doing a variable here and blah blah blah? So could we not have written just R equals A plus B? It is true. It is going to work the exact same way. I just find it a little cleaner to do it the other way, just because it's easier to read. And when the component is a bit more complicated, I just like to keep things separate. I like to keep all the calculations in one place and then just have the outputs at the very end and be like, this is what we need to churn out of the component. Okay. It's just a personal practice, it's style. And from a performance standpoint of view, yeah, you are creating a variable, but that doesn't really make that much of a difference anyway. So I like this. So I'm going to go for this as the addition component, and we're going to leave it here. I just want to point out one thing. The addition component doesn't only, the vanilla Grasshopper one doesn't only add numbers, but it can also add other things that are addable. Like for example, it can add two vectors together. It can add complex numbers, I believe. So there's a lot of things that the component can do that we're not going to be fully replicating today, because I want to keep this at an introductory level. Okay. So let's move on to the next one. The next component we're going to do is going to be the list item component. And if you are familiar with this component, what it does is it takes a list of data. So for example, here I have written a panel with 5 numbers. And for those of you who might be curious, what I've done is to make it real fast, I've basically dropped a panel by doing 2 forward slashes, which is the shortcut for a panel. And then here I have double clicked and I have typed 0, enter 10, 20, and enter, enter, and 40. And then so that it becomes a list with multi-line data, I have right clicked here and I have typed multi-line, so that now it is a list of numbers that I can feed into this component. Okay, so for the list item component, what it does is it takes a list of data, whatever data, it doesn't matter, and then you can choose with the index number, you can choose which element you want to cherry pick from this list. Okay, I would like to remind you that in computer science it's very common to start index numbers with 0. So the first element of a list is usually element number 0, and the last element of the list is usually however many elements are in that list minus 1. So if your list has 5 elements, then the last element is usually the one in position number 4, is item number 4. We can see that very clearly here on this list here. So the index is going to be the position of the element, and you can see that as I go beyond how many elements are in this list, the component gives me an error unless I toggle the wrap function, in which case then the component just wraps the index numbers and starts from the beginning again. So 5 becomes 0, 6 becomes 1, 7 becomes 2, etc., etc. You can also notice that if I toggle false and I go as farther than how many elements are in the list, I get this warning set saying supplied index is too high. We are going to mimic that functionality because it's very good practice to give your users to give feedback about what's going on your component. It's a very good UI practice. So because if you're doing C# components, you're probably doing something that is going to be used by yourself or by somebody else. So this kind of interfaces or these kind of tooltips are really good practice to do. So so let's do that. What I'm going to do is I'm going to drop here a C# script component. I'm going to change the inputs. So I'm going to say this is going to be the list. This is going to be I, which is the index number. And I'm going to zoom in so that I get these buttons prompting me to add more inputs. So I'm going to add another input here that I'm going to call capital W. All right. And then for the output, I'm going to choose I, but that is actually not great practice because internally I would have two things, the input and the output of the component with the same name, which is going to be confusing for the component. So what I'm going to choose is, I'm not going to be able to do exactly the same name. I'm just going to choose to give the output this name, I out. Okay? Now, I'm going to plug in here the same stuff. So, I'm going to give these things types. So for wrap, it's going to be a Boolean, which means something that can be true or false. For I, which is the index number, I'm going to use an integer because I don't want decimal numbers here. And for list, this is going to be special because since this component can work with any kind of data, I don't want to bound this functionality to just numbers or geometry. I want to make it as generic as possible. And in order to do that, I'm going to choose the most generic type of object that exists in C#, which is the system object. So this is basically, imagine the system object as like the father of all data types and all types of variables in of something like that. Okay, it's the most general type of data that you can find in C# component. It's the one that all data types inherit from. And also very important, I have left item access for W and for I, but for L, because for this one particular component, I do not want to look at each one of the elements in particular, but I want to look at the list as a whole, so that I can cherry pick from each one of them. It is important that we switch from item access to list access, so that when we are inside of the component, instead of having access to only one element of the list 5 times, I want to have access to all the 5 elements all together with a list. Okay, this is very important for this one. I'm going to zoom in a little bit here, and then you can see that my inputs are L, which is a list of system objects, and then I, which is an integer, and a Boolean value for W. Okay, so I think we're good to go. So we can start like getting our code ready here. Great. The first thing we're going to do is we're going to implement just simply taking the one element that we need from the list, and then in a second step we will implement the checking. So make sure that there are enough elements to pick that index number, and we will then implement like the wrapping functionality. So let's get to it. The first thing that we're going to do is very simple. We're going to say, I want to declare an object that is the greatest type here. For example, datum, which is going to be, and then we're going to choose from the list that is coming in, we're going to choose the element that is in position I. So very easily we can just say from the list, I want to pick the element at position I, and I can use the square bracket notation to point to one particular element within the list. Okay. Now what I can do is for I out, I can output that datum component, that datum variable that I just created. Okay. So let's see if that works. Right now it doesn't work because I don't have anything connected here. So let me plug in here this and this and this, and then something else and you can notice, you can see that if I click here, it's giving me an error. Index was out of range, and this error is because I'm trying to fetch element on position number 7, which doesn't exist in list. And in my code, I am not managing correctly that situation, so the component is giving me an error. One reason why I like keeping the out component, the output of the component, is because I can get, if I plug in a panel, I can see those errors textually on the screen rather than having to hover over or clicking over the balloon. So that's one of the reasons why I typically keep the out component. Yeah. So first things first, that is a really good proof that we need to apply sanity and we need to do checks on our code. But let's first see if it works at a basic level. So if I say 4, I'm getting 4, 32, 10. So that looks like it's working. So it looks like at a basic level, the component is doing what it should be doing. So that's great. So now let's implement here some kind of error checking to make sure that that we are fetching the element in the right position. So how am I going to do that? I'm going to create first a variable that I'm going to name position, which I'm going to initialize to the value of I. So what I'm saying is you're giving me the index number. I'm going to keep it in this variable, but then I'm going to check if this number that you're giving me is correct. So for example, I'm going to say if position is greater than is greater or equal than the number of elements that the list has, then this is probably not good because you are asking for a number, a value that is outside the range of this list. So typically what you would do is like you would throw an error message here. So we can do that by saying component dot add runtime message and then Grasshopper runtime message level dot warning index is out of range, for example. And then here, because we don't want to keep working with this component, we want to stop the functionality. We don't want to hit this line of code, which would give me an error. What I'm going to do is I'm going to type return. Return will immediately finish the execution of the component and not continue with the code. I'm going to run this. Everything looks good here, but as you can see, as I move further up, when I hit 5, now I'm getting this error warning message that I have here. Index is out of range, which is similar to supplied index is too high. Maybe if I really supply index is too high, I'm going to run this and you can see that the error message now is exactly the same, is matching, all right? And you can see that there's no output. I'm not giving anything and there's no error. So this is a much cleaner solution. It incorporates checks, so that is great. But as you can see in the original component, if I click true, now it's doing the wrapping functionality. Okay, so it's figuring out a new position to pick it up. So that's probably something that I want to implement here as well. So I'm going to keep this true. And then what I want to do here is, okay, so inside of this check, if the index number is too far out, then I want to do two things. If wrapping is true, I want to calculate which one is the new position that I would fetch, but if wrapping is false, I want to do what I've been doing, which is just giving this error message, okay? So I'm going to write a conditional here. If wrapping equals true, or you can shortcut this by just keeping the if wrapping, then do something, we will figure that out. Otherwise, if it is false, then give this warning and stop executing the component, just like as we did, right? So this works. So now it's still working well when wrapping is false, but when wrapping is true, I still hit the error because I'm doing nothing here and the component keeps executing. So now I want to do something here to make sure that if wrapping is true, I choose a right value for the position, which I'm going to substitute here, okay? And how is that going to be? For this, I'm going to use the modulo operator. The modulo operator is an operator that gives me the remainder of an integer division with the number. What does that mean? It means that, for example, should I do, I'm gonna do, yes, let's do. So for example, the modulo operator is this guy. It's a percentage sign, and what it does is it tells me, it does an integer division, and it tells me how many elements are remaining in that division. So for example, if I divide 6 by 2, okay, 6 by 2, the result is 3. And what is the remainder? Nothing. Okay? If I do 7 divided by 2, and it's an integer division, so no precision, no decimal values, the result is still 3, but I have 1 unit that is remaining. No? If I do 8 divided by 2, the result is still 3, but I have 2 units that are remaining from this division. So that is exactly what the modulo operator does. So, so if I say, for example, 6 modulo operator 2, sorry, 3. What am I doing here? Yes, modulo operator 3, the result of this operation is 0. So the remainder of the division is 0. If I say 7 modulo 3, the remainder of dividing 7 by 3 is 1. If I say 8 modulo 3, the remainder is 2. And if I say 9 modulo 3, the remainder is 0 again. This is very useful because if we say, give me, I have elements in position 0, 1, 2, 3, and 4. But if I reach element 5, I want the result to be 0. So we can achieve that with the modulo operator. So how are we going to do that? If this is true, then the variable that I've defined as position, so post, is going to be equal to the value that you're giving me modulo the length of the list. So L dot count. And if I do that, you can see now that we are getting, so we are at 4, and as we switch to 5, we go back to 0, and as we switch to 6, we go back to 1, 2, 3, 4, 5, 0, etc. And if we turn this off, we get the warning message that we have been discussing. All right, so it looks like this is ready to go, and it mimics pretty well the original component. Okay, so we got it. That was list item. The next component we're going to work with is going to be the series component, which is a very interesting component. It just takes a starting value. It takes how many elements I want to generate in this series, and it takes the step size between those elements. And what it gives you out is a list of the numbers that start with this initial value, that many values, and the difference between them. This is a really good exercise because we can train for loops with this component in a very programmatic way. So let's start doing it. I'm going to write a C# component here. I'm going to rename the input, so that's going to be S, that's going to be N, and then I'm going to add a new one that is going to be called capital C, and then the output is going to be S out. Okay, I'm going to plug in a panel here, and then I'm going to plug in these guys. And remember, we always need to change the input types and the input access. Because for this one, I'm going to be outputting, I'm going to be taking single elements. I'm going to keep these item accesses as items. I'm going to keep the access of the inputs as items, not as list or data trees. But I will need to change the types. So for S is going to be the starting value. This can be any number with or without decimal part. So I'm going to choose double. For N, which is the step size, this can also be any number with or without decimal value. So for that, I'm going to choose double as well. And for C, which is the amount of elements in the list, this cannot have decimal value. So for that, I'm going to choose an integer type. Okay? And then I'm going to go in here. I'm going to zoom in a little bit, and then we're going to write a for loop that is going to it's going to populate a list with elements that are going to be output by this component. Because what I want to output is going to be a list of data. The first thing that I need to do is I need to declare that list before starting to populate it with the values that I want to create. For this, I have two options. I could do, for example, an array of double values or a list of double values. I will talk in some other workshop between the difference. I will talk in detail between the difference between arrays and lists. But long story short, arrays are give you better performance if you know how many elements you're going to be storing and if that is not going to change over the course of your computation. Whereas lists are much more flexible, so you can add, remove elements, and they can expand, they can contract at the expense of like a tiny bit of more computational time. Okay, but at this level it's not very important. So perhaps I'm going to start with a list, and then maybe we can also just real quick just implement the same thing with an array. It doesn't really matter for this example, because I know as part of my inputs, I know how many elements the list is going to have. So I know I can use that for creating an empty array and populating it. So let's start by creating a list of values. So that's going to be list. I open angle brackets to define that the type that this list is going to hold is going to be doubles, so numbers with repetition value. And I'm going to call this nums. And I'm going to initialize this as an empty list by saying new list, then angle brackets. I'm going to type the type again, double. I'm going to close angle brackets, and I'm going to open and close parentheses to indicate that this is an initialization, that I want to start an empty array, an empty list. Okay. Now, the next thing that I'm going to do is I am going to use a for loop to go over all the elements that I need to generate, compute each one of them, and then add it to the list. So I'm going to open a for loop where I'm going to say, I'm going to create a value called I, which is going to start at the number 0, which is going to be less than how many elements I'm going to create, and which is going to increase by 1 in each loop of the for loop. I have not recorded a full list of C#. Let's learn how to program in C#, but I will hopefully do that sometime soon, so check back on the channel about for loops and how these are done, okay? And then the next thing that I'm going to do is I'm going to say, well, for each one of those values, I'm going to compute which value I should output from the list. So that is going to be double val, for example, or v, is going to be a number that I need to calculate. The rule here is that the starting value is s, all right? And then the step size between each one of the numbers is n, okay? What that means is that if I have a for loop here that goes from 0 to 5, 7, 9, 100 elements, it means that each one of the elements on the list is going to be equal to the starting value, so 5, the base value, plus how many elements I have generated times the step size between those elements. So you can see that the first value is 5 plus 1 time 0.007. You can see that the value of 6, the second element, is 5 plus 2 times 0.5. So here we can say the value of each one of these numbers is the value of the base value, so that's s, plus how many times, plus the step size, which is s, times how many elements, so the number of this element within the list. So times I. And then once I have computed that value, I can say nums.add this value to the list. Let me see if anything is working. Well, something is not working. Yes, I have a typo here. This should be a parenthesis, not a square bracket. And as I run this, something is not working also. The error is that blah, blah, some invalid arguments. What am I doing here? Can I convert from list double to double? All right, I'm going to pause here. Yeah, sorry for that. I just realized that I was doing something very stupid. I was adding the list inside of the list, which makes no sense whatsoever. So it was just a typo. I need to add the value that I just calculated to the list of numbers. Okay, and as I do that, this works fine. I still don't get the result because I need to specify that S out, the output of the component, needs to be equal to that list that I just generated. Okay, so I'm going to click execute, and you can see that this looks like it's working fine. So I get more or less elements. I get more or less step size between them, or I can shift the this. I don't know why this is an integer. This should definitely have decimal part. All right, but it looks like they work pretty well. All right, so that's great. Let me just real quick do the same thing with an array, just for the sake of illustrating this. I'm going to comment all of this out, just to keep it here as part of the doing it with a list. But now here, very similarly, I can just say I'm going to create an array of nums, which is going to be a new double array, which is going to contain C elements. C is the number of elements that I'm going to add to this array. And then here, I'm just going to copy paste the for loop, and I'm going to say double value is the same thing. Okay, and then here in nums, and then in position number I want to store the value of val. And then as I do that, the component works exactly the same, and yeah, it works well. Okay, so that was number series. I think this was a really good exercise to do for loops. It's so good that I actually want to do another one, which also involves for loops, which is going to be numerical ranges. So let's do it. I have created here a range of numbers by first constructing a domain. A domain is an interval between two numbers, and then specifying with the range in how many divisions I want to chop this domain. Okay. So how am I going to do that? As usual, I'm going to drop a C# component here. The input is going to be D. Then this input is going to be N, and then the output is going to be R. And then for the input types, I'm going to do the following. N is going to be an integer of access type item, just because I want to chop something in whole numbers, not with decimal part, so integer. But for domain, I'm going to choose here the data type interval, because for some reason, domain is how things are called in Grasshopper, but interval is how domain ranges are called inside of Rhino Common. So I'm going to type here interval. I'm going to place this here, and then now I can start typing here my code. The first thing that I would like to do is, if I have a domain, so something that goes between two values, in this case 1 and 3, and I want to divide it in 5 segments, what I need to do is I need to first find out what is the size of each one of those segments, so that I can then create a for loop to go from the first number and then iterate. Okay, so what does that look like? I'm going to say, for example, double step is going to be equal to the how long, so what is the length of this interval, divided by how many times I want to chop this interval on. So I can say d dot length, and you can see that what this is giving me is the signed length of this domain. So in this case, it's going to be 2, positive 2. And the interesting part is that if this domain went from 3 to 1, then the signed length would be -2, which is very good also for calculating the step. So I'm going to choose length, and I'm going to divide this by how many steps I actually want within this domain. Just for the sake of making sure that things are going well, I'm going to print something to the output of my component. So I'm going to print step size plus and the number of step. I'm going to do that. I'm going to plug here a panel, and then it looks like step size is 0.4, which looks correct according to what I had before. So this is looking good so far. I'm going to now then write a for loop that starts very similar to what I did before. Starts with the base value, which is going to be the first number of the domain, and then starts adding based on how many elements do I have. So I'm going to create a list of doubles, for example, which is going to be nums new list double, yeah, this happens a lot, list double, okay, and then I'm going to write a for loop that is going to start at I0, I is going to be less than n, but at this time, this is something important to notice. If I'm going to divide a domain in 5 segments, then the result is going to be 6 values. Can you see that here? Because we're also incorporating the both ends of the domain. So in this case, I don't want to be less than n. I want to be less or equal than n and I++. And then, very simple, just like I did before, I'm going to create a variable called value. This value is going to be equal to the base value, which is going to be d dot t0, which is no, is t0 or is it start? No, it's t0, which is the initial value of the domain plus the step size times how far off we are on this list. Then nums equals nums dot add value, and then the output is going to be r, is going to be the values of nums. I'm going to click that, and I had a typo somewhere here. All right, I'm going to fix that typo, and as I do that, I'm going to switch here, and I can see that I get these numbers, and that if I change the step size, I get more or less elements, and that if I switch these guys around and make the starting point higher than the ending point, I still get the right range in the good sequential order. All right, so this is great. Another one implemented. Great. So enough with numbers. I think it's time to move on to some geometry, right? That's why we're all here. So let's start with the simplest kind of geometry that I can think of, which is a point. Okay. I'm going to mimic the construct point component, which takes 3 numbers, and then it just gives you this point in x, y, z coordinates on the viewport. Okay, that then you can manipulate and work with. So very simple. Let's start with the C# component. We have like, I'm going to uppercase this x, I'm going to uppercase this, I'm going to uppercase this y, and I'm going to uppercase c, and I'm going to say that all of these guys must be doubles. Okay. So right click, double, because they can be numbers and with decimal part, and the output is going to be pt. Okay. I'm going to plug this in here, and I'm going to go in, and I'm going to double click, and I'm going to start writing my code here. But before we do that, I would like to make a really quick comment. We're going to start working with geometry, and geometry is not anymore part of what comes out of the box with C#, with the plain programming language. All the geometry goodness that we have inside of Grasshopper is thanks to this thing that is called the Rhino Common. And Rhino Common is basically a library of geometry objects that lives on top of the C# programming language that is running under the hood in Rhino and in Grasshopper. So a lot of what I'm going to be showing today, if you Google Rhino Common and you go to the Rhino Common API, a lot of what I'm going to be showing today in terms of geometry doesn't belong anymore to vanilla C#. It belongs to the Rhino Common library that is inside of it, and most of it is actually inside of rhino.geometry. And you can see how here we have angular dimensions, curves, B-reps, we have hatches, we have meshes, we have matrices, we have NURBS curves, we have a lot of really good stuff. This is what makes Rhino and Grasshopper so powerful, okay? So we're going to be using this API, we're going to be using this application programming interface, because this is the power that Grasshopper is giving us. And we know that because you can see that as I extend the C# scripting component at the beginning, you can see that it's using all these native libraries, but it's also using all these libraries that come with Rhino and with Grasshopper, which is a very interesting thing. If you want to learn more about Rhino Common, I do have here on my Harvard playlist, I do have a video somewhere where I actually go over Rhino Common and I talk about the different types and I talk about how to read the documentation. So if you want to learn a bit more, feel free to go and check this resource. Okay? Now enough with the self-promotion. So how are we going to do this? Well, it's going to be super easy. The first thing that I'm going to do is I'm going to declare a variable, but now this time it's not going to be a number or a boolean or a list. It's going to be an actual point object. I'm going to declare a variable of the type point3d, which doesn't really stand for 3 dimensions. It stands for 3 doubles, which I'm going to call p. And I'm going to initialize, I'm going to create a new object by using the constructor syntax, which is new. And you can see that I already got an autocomplete that says point3d. And as I do that, I open parentheses and it gives me all the options. So if I tap with the arrow keys up and down, it gives me all the options of things that I can use to create a new point. So 3 doubles, a vector, another point, etc. So because I have the 3 components, I would like to use those. So I'm going to use X, capital Y, and capital C. And then on the output, PT is going to be equal to this new point that I just generated. Okay? As I do this, I'm going to turn this off so that you know for sure that this is the one that I'm creating. Because it goes green, you can see that the components are the same. And this point here is now a point that I could plug into any other component down the road. Okay, which we're going to do right now because I'm going to extend this block to also deconstruct the point. Okay, stay here with me. What you see here, what I have written right now is I have added down the road after construct point, I have added a component that is called deconstruct, which does the exact opposite operation. It takes a point and it outputs the 3 components of that, the X and Y and Z component of that point. So I have created also a C# script component that I have changed the input and output names. And on the input, I'm going to right click and I'm going to choose the right input data type for this P parameter. In this case, it's not going to be booleans or point or doubles anymore. It's going to be geometry objects, like for example, point3d. And then I'm going to plug this in here. And as I double click, you can see that I have a point3d object as the input and 3 XYZ coordinates that are the outputs. Okay. What's interesting about this is that classes and structs, which is what point3ds are more complex objects than just simple numbers or simple booleans. And you can think of them as buckets that have information inside of them, information that has names attached to it. So for example, if I say, I want to take a look at the element P, the point P, and see what's inside, I can use the dot notation, and then this, I can use the dot notation, and you can see that this pop-up window will show me, for example, all these purple boxes are the functionality, the methods, the functions that are inside a point. So I can compute the distance to something, I can compare it to something, I can interpolate with other points, and the properties that has this wrench symbol, those are values of some kind. So for example, is this point valid, or is it coming from a faulty operation? Or for example, and this is the important ones, the X, Y, and Z values of this point. So these are the things that I would like to output as part of this component. So for example, what I can do is I can say the capital X, which is this object here, the output, is going to be equal to the property capital X of point capital P. The fact that they're both called uppercase X is just coincidental. It doesn't really mean anything. They could be called whatever else. But it's important that is a very important distinction to make. So the output of this component Y is going to be equal to the property Y of the point, and the output of this component Z is going to be equal to the property of this point Z. And as I do that, this works well, and I can change my inputs and everything works as expected again. Okay, so that is the basics of creating basic geometry objects and deconstructing those geometry objects to fetch their parameters. Okay, let's take a look at some more of this. Another thing that I would like to do, for example, is I want to take a look at vectors. And for those of you who know me a little bit already, vectors are one of my favorite things in computational geometry, and they're extremely useful for so many reasons. So much that some of my friends actually call me Dr. Vector. So, but I don't wanna give that too much publicity. So, let's take a look at how to work with vectors, and let's do like a few components that work with them. The first one being we're going to take a vector and we're going to find its length. So how are we going to do that? Very simple. C# component. This is the v input, which is a vector. So I'm going to right click and say that it has to be the vector 3D type, and then the output is going to be L. Okay, and I'm going to plug this in here, and then I'm going to paste here a couple of panels, and then let's write some code here. So if you guys are familiar with vector geometry, I'm actually going to go back to the Harvard playlist, and I'm going to, if you guys want to refresh a little bit of your vector algebra, I do have a full list here where I go over vectors, vector properties, how to compute the length of a vector, how to do dot products, how to do cross product, and the geometrical meaning that all these operations have. So also feel free to check it out. I think it might be useful. So if you guys are familiar with vector algebra, to compute the length of a vector, what you do is you do the square root of the sum of the square values of each one of those properties. So there are two ways to do that here in the Grasshopper world. One is to do it manually, so to actually write the equation that computes the length of a vector, or to use the API in Rhino Common. So I'm going to do both because I want to show the difference. The first one would be just writing it manually. It will be a value of the type double because it has decimal part. And what I'm going to do is remember, I'm going to vector length. Remember that the length of a vector is the square root. Where is this? Well, this looks terrible. Okay, images, what is the formula? Here. So for 3D, the length of a vector is the square root of each one of its coordinates squared. Okay, so how are we going to do that? First, we're going to add them. We're going to add them together. So that's going to be Vx multiplied by itself plus Vy multiplied by itself, so the y property of the vector, plus Vz times Vz. So what you've seen here is that I've taken each one of these values and multiplied it by itself. I could have done, I think there is a function called math square. No, there's math power, where you can elevate one number to the exponent. So we could have done this for each one of those values, but it takes a little bit more computational time and it has to call the functions. This is much faster. But remember that we need to do the square root of that value. So for that, what I'm going to do is I'm going to say math dot square root, and then I'm going to open parentheses and I'm going to compute the square root of this whole thing that I just cranked. And then the output is going to be L equals length. I'm going to output this, and you can see that the values match. So it looks like I got my vector algebra correct. Good stuff. The other thing that I would like to show you is that one of the nice things about working with a geometry API is that a lot of these operations are usually found very commonly within the API. So it turns out that, for example, the vector class, so this guy, does have all these properties, x, y, z, etc., but it also has a lot of goodies to doing common operations, like for example finding the length of a vector. So something that I could have done instead, I could have said double len, but instead of computing this manually, I could have used the vector object and look at all these properties. So you can see it has like all this stuff here, x, y, z, unitize, square length, whatever, and one of the properties that it has is length, which gives me the magnitude of this object. So I can just access this property and I would get the exact same value, but instead of doing it by hand manually, I do it with the Rhino Common API. Okay, but it gives me the exact same result. Okay, wonderful. Let's do a little bit more of vector algebra, which I think is really cool. Let's do dot products and let's do cross products. Great. What I have done here to start with the dot product is that I have created two vectors, and then I am using the dot product component to multiply them together. And if you remember, the vector dot product, if you remember, the dot product of two vectors is an operation that gives us a number in return. It doesn't give us a vector, it gives us a number. It's basically, the operation is basically the multiplication of each one of the components one by one. Again, if you want to hear more about this, this is actually the vector, this is actually the dot product that I'm showing right now on the video. And if you want to hear more about what the meaning of the dot product, for example, which is very useful to compute angles between vectors, check my video there. And what I've done is I have a C# component. I have already written all the inputs and the outputs, and then each one of the inputs I'm going to choose the right type for them. So A is going to be a vector 3D, B is going to be a vector 3D, and U is an input that tells me whether if I want to unitize the vectors before multiplying them together. So this is a true or false statement, so it will be a Boolean value. Okay. So let's go here, and again, I can do this in two different ways. I can do it the Rhino Common way, or I can do it the manual way. I'm very much of a manual person, so I like teaching things low level, so that you know how things work internally, and then you can do whatever you want in your life afterwards. So I'm going to do it both ways. The first thing that I'm going to do is I'm going to ignore for the time being the unitizing part. And what I'm going to do is I'm going to compute with the double, I'm going to compute the dot product, and I'm going to do that by saying A dot, I basically need to multiply each one of the x and y, z components of the two vectors and then add those results together. So that is the meaning, that is the algebra behind the dot product. So A dot x times B dot x plus A dot y times B dot y plus A times C dot B times C. If you guys were in my Harvard course, you would actually do this for homework. I have a homework which is just like replicate a ton of like vector and points and algebra components. And then D is going to be equal to dot, which is the dot product that we just calculated. As we do that, you can see that this is working, right? Except when I unitize these things. Unitizing means taking a vector and scaling it down so that the length of that vector becomes 1. Right now, I have no idea how long these vectors are, but they're probably not 1 unit long. So there are two ways to do this as well. Unitizing a vector is equal to taking that vector and dividing each one of its components by the length of the vector. We can do that manually, or we can use Rhino Commons API. For this one, which is much faster, I'm just going to use the Rhino Common API. So what I'm going to do is if U equals true, or this, which is the same shortcut, what I would like to do is before performing any operations with the dot product, I would like to A dot, I would like to unitize this vector, the vector A, and I would also like to unitize vector B, so that when they reach this point, they are vectors that are 1 unit long. As I do this, I'm going to now hit true, and you can see that vectors have been unitized and the result is consistent with the original component. Okay? The last thing that I would like to do is I would like to show you guys how to do dot product natively with Rhino Common. It's also very easy, so you can just say A times B, and this this may sound crazy, but this kind of syntax also comes from Rhino Common, from the fact that you can multiply directly two vectors. And because multiplying two vectors, the meaning is the actual dot product. So if I do that, I got my dot product value, and I am uncertain whether if there's like a third way of doing this, which might be vector 3D dot multiply. Yes, there is. But this is this is two vectors. So this would be a third way of doing it, which would be double dot, and this would be taking the vector 3D class and looking at the multiply static function, and then seeing that you can multiply two vectors together, returning the dot product. You can actually see that from the documentation. So I can multiply A and B, and the result will be exactly the same. So there you go. This is the dot product. Let's get on with the cross products now. So I have added to what I just did before. I have added a new component, which is the cross product, and I have added its same C# script, and with the names, with the inputs and the outputs, and with the right types for the A, B, and U inputs. If you would like to know more about what the cross product means, it's actually a really interesting operation, because what it gives you is is the multiplication of two vectors, but instead of giving you a value, what it gives you is a third vector that is perpendicular to both of them. So and it's the result of doing a determinant operation on a matrix of those two. This is the formulation here, and I think I have an animation somewhere here that gives us like a visual. Yes, here it gives us like an interactive. So this would be the result. The blue arrow is the result of the vector multiplication of these two. You can see that it's always going to be a perpendicular vector to the plane in which those two vectors are oriented. The cross product is one of the most common operations in vector algebra, especially in computer graphics. It's really, really important that you guys understand it. The length is also proportional to the angle at which those two vectors are. So let's do it then. So here I got vector A, vector B, and remember, the result of this operation is not a number anymore, it's an actual vector. So I can do this, I can do vector 3D is going to be, and I'm going to call this cross, and I can say, for example, I can use the Rhino Common API vector 3D dot cross product, and then I can open, and be A is going to be the first vector, B is going to be the second vector, and then the result is going to be cross. As I do that, you guys get to see. Oh, I forgot to actually replace this. Is not the cross. This is not this is not, wait, I am not doing this correctly. I had not, yes, so this is the vector, and L is the length of the output of the vector. So let me redo that. This is not great. V is cross, all right, and L is is the length of that vector. So let's see if this works. Okay, so sorry, this should be cross. Yes. Okay, so you can see that I'm getting the two vectors, the two outcomes are the same. if you, because we have to implement the unitize part as well, we can do the similarly as before. If it's true, then take A and unitize it, then take B and unitize it, and then after that perform the operation. Okay. We could write this manually. So I showed before, this is the formulation. Where is that? This would be the formulation. So x, y, and c would be x times c minus c times y of the two vectors, etc., etc. But it's a little tedious. And honestly, I never remember it off the top of my head. So for this, I would just recommend you go straight with the Rhino Common API. Okay. All right, and I think the lesson that I would like to do for this tutorial is I would like to show you guys how to create lines between points, for example. So let's get that going. And last but not least, let's do a simple line between 2 points. That's actually going to be super straightforward given what we've done already. So I already created 2 points, and I already have my line component in vanilla Grasshopper, and then I dropped a C# script component. I changed the names of the inputs and the outputs, and I still need to set the type of each one of the inputs to point 3D. Remember, this is very important. We tend to forget about this. I'm going to double click here, and then this is going to be extremely straightforward. Just like Rhino Common has point 3D objects, it has vector 3D objects. It also has line objects. So we can create a variable of the type line, call line, lowercase line. And remember that C# is case sensitive, which means that uppercase line means the Rhino Common class. So it's a type of data that we can use in Rhino Common. And lowercase line doesn't mean anything for Rhino. So we can use that as a variable name. It's a little confusing, but you will see that happening quite often. So I can use the constructor syntax to create a new line object, and I can scroll through the options with my arrow keys. So I can use, for example, 2 point 3D objects. I can use a point and a vector to create a line. I can use a point and a vector and a length, and I can use the 6 coordinates of the first point and the second point. So x, y, z, blah, blah, blah. Because I already have the points, I'm just going to go for the first overload of the constructor and say I'm going to create a line between A and B. And then I'm going to output this value in my output L. And as I do that, boom, I already have a line here in my viewport that is linked to the 2 points at the input. Great. Okay, so I think that's it. I think I covered less than I wanted to cover in this video. So maybe this is going to become part 1 of like a series of like, let's deconstruct some Grasshopper components and see how we could replicate that functionality with C#. Okay, so stay tuned for more videos about this. They will be on the link here in the comment section in the description. There might be a card popping up somewhere on your screen. And please remember to subscribe to the channel. And if you want to get notifications when new content is coming in, just click on the little bell, and so that I can nag you with emails like more stuff, more stuff, more stuff. All right. Okay. Thank you very much, and stay tuned for more in this series of GH#, Grasshopper#, or deconstructing Grasshopper components. Okay. Thanks a lot.